In my opinion, this choices are 1 plus 2 or 4. Obviously 4 is greater, so I'm going to choose 4. That means we put a 4 right here. And this last 4 means that for the entire array, the max value we could get is 4 if we wanted to rob houses. So we can put a 4 here. But notice how we don't even have to store this entire blue portion. For each value, like for this one, 4, to compute this, we only need to look at the previous 2 results that we computed. And the reason for that is because we could either decide to rob this. One and rob the remainder portion of the array, not including 3, in which case we'd have the value computed right here. The other case is if we wanted the max we could rob from the entire array, we could decide to not even include this and just get the max from these 3. And in that case, the value would be stored here. So now let's look at the code. Since we only need to maintain the last 2 maxes that we could Okay, let's solve LeetCode 198 House Robber. In my opinion, this is such a good question to understand. Even though it's just an easy question, you can learn so much about dynamic programming from this problem. And you might already know, Google really loves asking dynamic programming problems. Here. We need to maintain the last 2 maxes that we could rob from. We'll only need 2 variables, so I'll just name them rob1, rob2. We'll initialize them as 0 because if we get an empty subarray, we want to return 0 anyway. So let's iterate through each of the houses we can rob. And now we want to compute the maximum that we can rob up until this value n. So I'm going to compute that in a temporary variable for now, and you'll probably see why. So the max we can rob up until now, in my case, I'm going to say rob 1 or rob 2 was the last house that we robbed. Rob 1 was the one before that. So knowing that, the max we could get would be n plus rob 1, meaning there's a gap between the current house and the previous house, or rob 2, which includes the previous house. In case it's not clear, this is basically, let me just make a comment to show what I mean by rob 1 and rob 2. So rob 1 is first, rob 2 comes second, and then we get some more values, n plus 1, and so on. So if I want to rob n, then I have to rob 1 as well. I can't use rob 2. But if I want to do rob 2, I can include n because it's right next to it. So when we iterate to the next position, meaning we get here, we want to update rob 1 to now equal rob 2. So let's do that. And rob 2, in this case, wants to be updated to n. So rob 2 can now equal our temporary value that we just computed. At the end, we want to return rob 2 because by the time we get to the end, rob 2 will be equal to the last value, meaning
solve the game of life. Hi everyone, we're here today for another Exponent mock interview with Simon. For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview questions.
In terms of the output, like in terms of getting the next state, do you want me to return an entirely new copy of the grid with the updated values?
I'd prefer if you could do it in place.
Sure. Yeah, I think that makes sense. We probably want to be space saving. Would you be able to show me some example input and what we think that the next state would look like?
Sure, yeah. So for an example, I'll put that together with the instructions.
Yeah, this is starting to make sense. And this might be an assumption, but the cells outside of the grid, are we just assuming that they're considered dead, that they have a zero value?
Yes.
Why don't we go through some of the actual cells and kind of reason about why they changed the way they did? So if we kind of look at the initial state, um, this cell, for example, it died and turned into a zero over here. And the reason for that is because of rule number one.
Really, the big focus of this interview is going to be technical skills. Most interviewers are going to run a few warm-up questions, one main question that's going to take the bulk of the time. So you can imagine a 30 to 35-minute interactive question.
The questions themselves aren't going to have the answer presented to you directly. You really have to understand what the question is asking and have an understanding of different data structures and algorithms to be like, okay, I can mix and match this together a little bit to make this happen. And then you can build on top of anything you have to do inside the actual interview.
For my experience, all the interviewers from Google are extremely nice. So they are very supportive and helpful. Even though the first solution you come up with might not be the best, they will guide you through, give you enough hints, so eventually you can get the best solution. You definitely need to think out loud. First, ask clarification questions. Second, call out assumptions. Third, you need to explain your thoughts clearly before jumping into coding.
It's like, what are your edge cases? Define those first. Is anything going to be null? What kind of inputs are you getting? So you can make sure that your system won't break halfway through. Definitely speak out loud so that your interviewer knows kind of where your mind is on certain things. And that's when they can give you like hints every now and again. Like, oh, maybe you don't use a hash set. A hash map might be a little better.
I think a lot of people come into it with the misconception that for every problem you're given, you must find the algorithmically optimal solution. But it's better to find some solution than none at all. That's really easy to mess up.
The biggest piece of advice of how to do well at a software engineering interview is to not try to do well at the interview, but how do you do well as a software engineer in general, right? And that comes with practice, that comes with knowing your code. So you really have to do what you have to do to make sure that when you do get on site, you crush it.
I'd recommend the Google Tech Dev Guide to make sure that your fundamentals are going to be strong for the interview. Make sure that you're really good at least one language, because you're only going to get to pick one when you do the interview.
Prepare yourself, get used to code on a whiteboard. The difference coding on a whiteboard and coding in an editor is that you don't have any helpful tools to guide you through to finish the syntax.
So it's easy to just practice writing some code on a piece of paper or where you don't have that type of tool. I think there's a misconception that you need to be like the best engineer ever to work at Google. You don't need to be an expert at algorithms. You just need to be good at them. You don't need to know some really high-level, complex data structures. You just need to know all the basic ones really well.
You kind of think of Google as this like super software engineer producing entity, but then you realize it's people that have also been through your same process, right? They practice, they worked, they developed to be who they were today.
Of course, Google likes to hire smart people, but don't underestimate yourself. You can do it.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem decode ways. So we're basically given a string of integers, and we want to know with that string of integers, how many different ways can we take that string of integers and decode it into a string of characters. And we're given a specific mapping, so we have 26 characters, and each integer maps to a different character. So we have an integer 1, 2, all the way to 26, and each of these integers maps to a different character. Now, we don't actually need to build that string that we are mapping to. We just have to count the number of different ways we can decode it. So down here in the example, you can see a string like 12 can be decoded in two different ways. One way to decode it is just 1 and 2, because 1 maps to A, 2 maps to B. So that's one string, but remember, we can have double-digit values, so 12 actually maps to its own character. 12 itself maps to 11. So there are two different ways that this string of integers could be mapped to a string of characters, so we return 2 in the output. Now, as you can see, it would be very simple if we just had numbers 1 through 9 that map to characters, right? The problem comes from double digits, right? From 10. 10, a string like this can be taken in two different ways, right? 1, 0, or just 10, right? So that's where the complexity is going to come from. From a string like this, we could have two different decisions. So we're going to be using a decision tree to kind of figure out all the possibilities with this. At least that's going to be the brute force approach. The only problem is that there's going to be a few different edge cases we have to worry about. For example, we could have a string like this. We could have a string like 0, 6, right? What exactly does this map to? Well, 0 is not even in our input, right? Basically, 0 itself does not map to any character, right? 6 could map to a character, but 0 does not. So if we ever get a 0, a string starting with 0, that's invalid. So we have to return 0 in that case. This cannot be mapped to any, this cannot be decoded in any way, so we return 0. Okay, let's try to figure out the brute force approach to solving this problem, and in doing that, we'll try to figure out some of the edge cases that we're going to have to deal with. Suppose we have a string like this, 1, 2, 1. How many different ways can this be decoded? Well, let's say we start at the beginning, right? We could take 1 by itself, right? That's going to be some character, right? We don't really care what it is, but it's going to be some character. Now, we could also take the first 2 characters by themselves, 12 by itself, right? Because that's valid, right? So that's another decision. Starting from here, we could take 1 or we could take 12. And by the way, if this was a 0, we definitely could not take it. Then we'd have to just stop immediately, right? Because we can't start with a string starting at 0. But if we had something like 1, 0, right, a 10 maybe, then we can take it because it's okay if a 0 comes after a 1. And so basically any integer by itself, right, 1, 2, 3, 4, 5, any integer by itself except for 0 can be taken, right? So basically we can create any string of one number from 1 through 9 except 0, right? We're just not including 0. It cannot be taken by itself, but any from 1 through 9 are okay, right? So what we're going to see here is, okay, if we went down this path where we chose a 1, then the next character we're going to be at is the 2, right? Of course, 2 can be taken by itself, right? Any number except for 0 can be taken by itself. It can be decoded in that way. So when we're at this 1, or when we're at this position, we can take 2 by itself, or we can take 21, right? 21 is also some character. I don't know what it is, but remember, we had values from 1 through 26, right? So having a 21 is completely fine. That will decode to its own character, right? Now, of course, if we had something like a 27 over here, then we could not go down this path, right? Then we just would not go down this path because 27 does not map to any character, right? So we're kind of learning that, the integers have to be within 1 through 26, right? And this 27 is not. Okay, and so down this path, we reach the end, right? We had a 1 and we had a 21, right? So there's no more characters to choose from here. So basically, this was one way that we could decode this input. So when we reach the end, we're going to count that as a 1, right? That means we found a single way to decode this input. So this was a good base case where we return 1. And from here, let's continue this one. So we left off at 2, then we get to 1. Can 1 be taken by itself? Of course it can. It's not a 0, so we can take it by itself. And so then we reach the end of the string again. So this is another good base case. 1, 2, 1 is a valid way to decode this string. So if we started with 1, over here, we could decode this in 2 different ways. If we start with 12, how many ways can we decode it? Well, if we start with 12, then we just have 1 character left, the 1 character. So that can be decoded another way. So this is another good base case. So basically, we saw that we have 3 different ways that we can decode this string. Now, just to kind of add a couple values to this string, what if we had something like 31 after it? So then, let's say we left off over here. We can choose the 3 by itself, right? Because any character except for 0 can be taken by itself. Could we take 31? We could not, right? The same reason we can't take 27. We can't take 31 because it's greater than 26, right? How are we going to determine that in the code? You can do it a lot of different ways. What I'm just going to say is we can only take double-digit values if the first digit starts with a 1. Because if it starts with a 1, then for the second digit, we can take anything from 0 to 9, right? Anything from 0 to 9, because then, this double digit value will either be between 10 to 19, right? And this value is less than 26. So that's perfectly fine. But if we start with a 2 digit, then the second digit has to be between 0 and 6 because 26 is going to be less than or equal to 26. But if this became too large, if it became a 27, that's not less than or equal to 26. So we can't do that. That's how I'm going to decide it. Now, what if the first digit started with a 3? Or a 4 or a 5 or anything? That's never going to work because if we're going to have some other second digit here, it's never going to be less than or equal to 26, right? It just won't be. So we're only going to have 2 decisions, right? We're only going to have 2 branches if our first digit is a 1 or if it is a 2. So this is kind of the brute force approach that I'm showing you. But it might not be super efficient because we could have 2 decisions at every single position. Then our time complexity would be something like 2 to the power of n, where n is the length of the input string. So how can we kind of do a little bit better? Well, notice the subproblem that we're doing. For example, when we take just 1 by itself and consider, okay, this is just going to be one way that we decode it, then we're asking, okay, how many different ways can we decode the remaining of the string, right? That's the subproblem over here. We're asking how many different ways can we decode 21. When we take the first 2 characters, 12, then we're asking how many different ways can we decode the string 1. Right? So that's kind of how the subproblem is going to work. The subproblem is just going to be some portion of the string, for example, starting from here all the way to the end of the string, how many ways can we decode this? Or how many ways can we decode this? Or how many ways can we decode the entire thing, right? To be able to solve this problem, how many ways can we decode this? We have to solve the subproblem, how many ways can we decode everything except the beginning. And so basically, how many different ways can we cache it? Well, we're going to have some index I, which could either be here, or it could be here, or it could be here. It's just going to designate starting from here and taking the remaining portion of the string, how many ways can we decode it? So basically, the dimension of our cache is going to be n, right? So that's also going to be the time complexity because every time we get to a position I, at most we have 2 different decisions to make, right? So that's going to be an O of 1 operation making those 2 decisions. It's not like we're going to have to run through a loop or anything like that. We're not going to have any loops. And you'll see that when I write out the code. If this is the size of our cache, this is also going to be the size of our time complexity. And this is also going to be the size of our memory. This is because it's the size of the cache. Now, just so you know, I think this problem actually can be solved when we write out the actual dynamic programming solution, not using a cache, not doing it recursively, but actual dynamic programming. It can be solved with O of 1 memory, because one thing you might notice, okay, when we want to know how many ways can we decode this entire string? Well, when we're at a pointer I, we can either take this character by itself, in which case then we're going to shift I by 1 over here and ask, what's the result of this subproblem? Or if we take the first 2 characters, 12, then we're going to ask, okay, what's the result of this subproblem, right? So we're either going to, so basically, to set dp of I, we're either going to ask dp of I plus 1 or I plus 2, right? Those are the only ones that we would need to look at right? To compute a value like this, we'd only need to at most look at 2 different positions that come after it. So, when we have our DP cache, we actually don't need a full array to solve this problem. We could do it with just two variables, similar to like a house robber